Hello everyone, how are you? I hope you all doing great. So welcome to EE Days, a multi-online education platform. So here you have to you can learn anything with ease. So by expert tutor. So before starting our session, so let me introduce myself. I'm Uday Kiran. I'm your maths academic specialist. I'll introduce our features and tools you have. So you have chat option with you. You can interact with me through chat with the live tutors. And in the live session, so we have if you have any doubts or anything, you can clarify your doubts with the expert tutors are there, and try to turn on your video in the session and turn off your audio. If you're facing any issues, so please intimate to live tutors, then they will resolve. Okay. After the class, so we have in-class session are there. I mean, you will be provided with the material. So exam preparation material, try to revise all the topics, and also recording sessions also there. If you have any doubts, just revisit the recording sessions. All right, that's it. So let's get started our session with the continuation of polynomials, where we stopped yesterday. Yeah. So yesterday we discussed about the degree of polynomial, types of polynomial. The first is nothing but types of polynomial based on the degree. If degree is 1, we call as linear polynomial. If degree is 2, let's understand. Yeah. Polynomial if degree is 1, we call as linear polynomial. And these are the example. A polynomial degree is 2, we call as quadratic polynomial. And these are the examples. And the polynomial degree is 3, we call it cubic polynomial. These are the things we already learned. Okay. Now, next type, let's understand the next type. Types of polynomial based on, this is what we learned in the previous grades. Type B. Now, once again, types of polynomial based on degree, based on number of term. So this is the based on number of terms. Okay, let's understand. I think already you people know, but we just brush up your knowledge about what we have discussed in the previous grades. Okay, in the polynomial p of x, in polynomial p of x, where number of terms is the number of terms is equal to 1, we called as monomial. All right. So for example, let me take an example. Let's take 2x. 2 and x is not different. It is grouped 1, 2x, and 3 is the monomial, or else minus 3x cube, u power 6. Okay, only one term is there. Okay, let's move on to the second type. In polynomial p of x, number of terms is 2. We called as binomial. Binomial bi is nothing but 2. Let's take an example. Can anyone please explain me what are the type of examples? Number of terms is 2. If number of terms is 2 is nothing but, let's take an example, 2x plus 3 minus y plus 5, or else minus 8 power 100, 8x power 100 plus 5. Why? Because there are two terms are there. Whatever the power and whatever the symbols are there, observe the terms only. There are two terms. Now, in p of x, number of terms is 3. So we called as trinomial. All right. So let's take an example. For trinomial, the number of terms is 3. So we can take it as x cube plus x square 1, or else minus y power 100 plus 2x minus 5. Okay, the number of terms is 3 here. I hope you understand. So previously we discussed about the number of type of polynomial based on degree. Now this is your second types of polynomial based on number of terms. All right. This is what we missed yesterday. Yeah, yesterday we discussed about the relation between coefficient and polynomial, right? Yeah, and also geometric representation of zeros of polynomial. If it is cut the x-axis, the polynomial equation where it cuts the x-axis, so you can take it as the number of zeros. So it is cutted at 2 points here. on the x-axis. So that's why the number of zeros is 2, like that. And already we completed exercise 2.1. All right. And we already solved the examples questions too. Okay, second exercise we already started. I mean the relation between zeros and polynomial coefficients. In there, we started with first write the general term, then first write the general term. What is the general term here? Ax square plus bx plus c is equal to 0. Ax square plus bx plus c is equal to 0. And now where we have stopped in the yesterday, the last session. Yeah. So here alpha and beta are the zeros. Alpha and beta are two zeros. Two zeros. All right. Now, you can take sum of zeros. Sum of zeros. This already we just discussed. For your reference, I'm saying again. You just write minus b by a. Minus b by a is nothing but here coefficient of x is b, and product of zeros. Product of zeros. Product of zeros. Alpha into beta. That is c by a. That is c by a. Okay. Okay, sir. So we already discussed all these things. If they given general term like this, now I how to frame the equation. Let's understand in the question. Okay, let's solve for example question. Then you can understand better way. Let's start with the example. Yeah, here alpha plus beta is equal to minus b by a, and alpha beta is equal to c by a. Let's start with example 2. Okay, here example 2 they given x square. Example 2. Okay, they given like x square plus 7x plus 10. 7x plus 10. So first you just compare with the general form. That is, what is that? Ax square plus bx plus c is equal to 0. Okay. In the place of a, what is there? So x square, if nothing else, you can take 1 here. And in the place of b, xx is common. And in the place of b, you just compare with the general form. You will get c is equal to 10 here. All right. Now read the question properly. Find the zeros of polynomial and verify that. Verify the relation between zeros and coefficients. Okay. I think you know how to find the zeros, right? Let's take, let two zeros would be, let two zeros are alpha beta, alpha comma beta. Now sum of zeros. Now sum of zeros. Sum of zeros, that is alpha plus beta is equal to minus b by a. Minus b by a. What is the b value here? Minus b is nothing but minus 7 by 1. Like now product of the zeros. Product of 0, that is alpha into beta is equal to c by a. C by a is nothing but, so substitute the value of c. C here is 10 and a here is 1. 7 by 1. Just stop it here. Okay, we did one part, find the number of zeros. Okay, we did sum of zeros and product of zeros. Now you can verify, like how to verify. I mean whether those are the zeros or not. How to verify that? Okay, let's verify by doing splitting middle term. By doing splitting middle term. Okay, what is the question here? X square plus 7x plus 10 is equal to 0. I already explained the splitting middle term, right? What is the first step? First, you should okay, just compare with the general form ax square plus bx plus c is equal to 0. Identify what is abc value. In the place of a, 1 is there. In the place of b, 7 is there. In the place of c, 10 is there. All right. The very first step is you just do one thing. So here you just multiply with a into c. A into c. What is ac here? The coefficient of x square, and c is constant term. So 1 into 10. So you'll get 10. Write the factors for 10. I just start with the first table. 1 tens are, and 2 fives are, and 5 twos are, and 10 ones are. These are the things. It should be matched with the middle term. What is the middle term here? 7 is there. Okay, if I add 1 plus 10, we'll get 11. If I subtract 10 minus 1, we'll get 9. That's why it would be cancelled. Well, there is no matching of middle term. Second one is, if we do subtraction, 5 minus 2, we'll get 3. Not matching. 2 plus 5, 2 plus 5 is 7. So that is why it is matching. So the we can write like this. x square. The middle term I just change the color. So we just write like 2x plus 5x, 2x plus 5x plus 10. You can write the remaining terms as usually, but only the middle term 7x I reiterated as 2x plus 5x. Let's take common from these two and these two. So here, if you take common x plus 2, you left with. And here, if you take common 5, so you just left with x plus 2. I think everyone knows, I already explained yesterday about how to split the terms, right? Okay, let's take common. X plus 2 is common from both, and x plus 5 is left. All right. Now, x plus 2 is equal to 0. Obviously, x is equal to minus 2. X plus 5 is equal to 0. Obviously, x is equal to minus 5. Okay, I got two zeros. X is equal to minus 2, x is equal to minus 5. Minus 5. I just taken alpha is equal to minus 2 and beta is equal to minus 5. Let's verify whether we are getting minus 7 or not. Sum of zeros. Sum of zeros is nothing but alpha plus beta. Alpha plus beta, previously how much we got? Minus 7 by 1 on the right hand side. Right hand side we got minus 7 by 1. Let's verify here. Alpha just now we got minus 2 and beta we got plus of minus 5. So minus 2 minus 5. So here minus 7 by 1. Here minus 7 by 1. Here also minus 7 by 1 is equal to minus 7 by 1. So we have equal both. So that's why you should verify the question. They asked that. Let's extend the question. Verify the relation between zeros and coefficient. After getting that, so you just do the splitting middle term. You can verify like this. Let's verify product of zeros. Product of zeros. Product of zeros. Previously, how much we got? 10 by 1. 10 by 1. Okay, I just write 10 by 1 here. Okay, product of zeros is nothing but alpha into beta, right? So alpha into beta is equal to minus 10, 10 by 1. Alpha into beta, what we get by doing splitting middle term, minus 2 into minus 5 is equal to 10. So 10 is equal to 10. So we verified both are equal. So LH is equal to RHS. You just verify like this, guys. Okay. X plus 2, x plus 5, we don't know how we got. So that's why I'm explain it by doing splitting middle term. Splitting middle term. After that, I'll get x plus 2 into x plus 5. That is x is equal to minus 5 and x is equal to 2. All right. I think you will get some idea how to verify that. So why? Because in the next exercise, you have a lot of sums based on the verification of zeros and coefficients. All right. Yeah, the same question, guys. Find the zeros of polynomial x square minus 3 and verify the relation between zeros and coefficient. The same procedure. Same procedure. All right. Let's see how to verify that. So, which example? Example 3. Example 3. What is the question they given? X square minus 3. X square minus 3 is equal to 0. Okay. First, do one thing. So first we need to find zeros, nothing but alpha comma beta. So if the given equation fulfill like this, x square plus 7x plus 10, then you can apply the splitting middle term. Split the middle term and find the zeros like this. Find the zeros like this. But observe carefully here, there is no possibility ways to split the middle term. In that case, you do one thing. So transfer 3 to other side. X is equal to x square is equal to 3. X is equal to root over 3 plus or minus root over 3. Okay. Now you can split like x is equal to plus root 3, x is equal to minus root 3. Okay. You can take it as alpha is equal to plus root 3 and beta is equal to minus root 3. All right. Now we got alpha and beta. Why we are waiting for? We just verify by substituting in the sum of zeros and product of zero. Sum of zeros. Okay. Before that, do one thing. So x square minus 3. Okay. Do one thing. Okay. The question here is x square minus 3 is equal to 0. Let's compare with the general form, that is ax square plus bx plus c is equal to 0. Let's compare with that. Identify ABC value. If nothing else, you can take 1 here. So a is equal to 1. B is nothing but x coefficient b. There is no x coefficient in the question. Only x square and 3 is there. There is no x coefficient. That is why b is equal to 0. C is equal to minus 3. C is equal to minus 3. Okay, I think you'll get some idea, right? So let's write it here. A is equal to 1, B is equal to C, B is equal to 0, C is equal to minus 3. Now let's verify with the sum of zeros. 1 second, guys. So let's verify by sum of 0. First, you need to write alpha, beta. Alpha, beta, what are the values we get? Plus root 3. I'm sorry. Plus root 3. Beta is minus root 3. Okay. Okay. So now the verification part, guys. Pay attention here. Sum of zeros. Sum of zeros. That is alpha plus beta is equal to minus b by a. Let's substitute all the values. Alpha, beta, just now we got plus root 3, minus root 3. Minus b by is nothing but here minus 0 by 1, minus 0 by 1. Root 3, minus root 3, you'll get 0, 0, 0 here. So we have to verify like this. Now let's try with the product of zeros. Product of zeros, that is alpha into beta is equal to c by a, c by a. So you can write alpha into beta is nothing but alpha into beta. So root 3 into minus root 3 is equal to c by a, that is minus root 3 by 1. Okay. Let's do it here. Let's do it here. Okay, root 3 into minus root 3. So we just write like this. Once again. Yeah, can I write like this? Root 3 into root 3. Can I write minus root 3 whole square? Already minus root 3 already there. By 1 is there. Square and root cancel. You'll get minus 3. Once again. I did somewhere mistake here. This is not root 3. See here 3, right? See here 3. We'll get minus 3 by 1, minus 3 by 1. Both are equal. RH is equal to LH is equal to equal. Okay. So we just verify any sums like this. So these are the example 3. Okay. So we have to verify like this. Sum of zeros we got 0. Product of 0 minus 3 by 1. Okay. Okay. Now the new concept would be, okay, sir, okay, we are aware of how to solve that, whether the equation after giving the equation like uh, if you given the equation like this, we have to first we have to do find the ABC value by comparing with the general form, and now we have some idea about how to find the sum of zeros and product of zeros. If they given equation, you can find the sum of zeros and product of zeros like this. But the next concept would be, what if they given sum of zeros and product of zeros? Okay, sum of zeros already they given as 4, and product also they given 2. In the question already given sum of zeros and product of 0. You no need to find completely. So in that case, do one thing. In that case, the new concept would be, yeah, this is the general form. Okay, this is the general form for if they given product of 0, sum of zeros. All right, I just write it here. You can write the expression like this: x square into sum of zeros into x plus product of zeros. Sorry, plus product of zeros is equal to 0. This is the important point. Okay, already they given sum of zeros is 4 and product of the zeros is 4. You just find the quadratic equation by x square minus sum of zeros 4, 4 into x, product of 0 already 2 they given. So you'll get x square minus 4x plus 2. Previously they given the question like this, and you need to find the sum of zeros, product of zeros. But this is the reverse process. They given sum of zeros and product of 0. You need to find the question. That is the polynomial equation. So this is the polynomial equation we got. All right, the reverse manner. So this formula is very, very, very important. I mean, only two conditions are there, two type of model. This is the second model. If the sum of zeros and product of zeros already given. Okay, let's solve the question based on this. Uh, yeah, let's try with example 4. Let's try with example 4. What is the example they given? Find the quadratic polynomial. This is the thing I just told you about that. Quadratic polynomial. So this is the format of quadratic polynomial. So we need to find. They asked that the sum of 0 and product of 0 already given minus 3 comma 2. Okay, sum of zeros. Sum of zeros. Okay, this is example 2, right? No, example 4. Okay, sum of zeros already they given minus 3 and product is 2. How to solve this one? So first you just write the format of how to find the quadratic polynomial. Let's write it. So x square minus alpha plus beta into x plus alpha into beta is equal to 0. Okay, all right. So here, okay, sum is nothing but alpha plus beta and product is nothing but alpha beta. Okay, let's substitute here x square minus 3 already there. Okay, I'm substituting with each and every symbol. Alpha beta is 2 is equal to 0. X square minus into minus, it is plus 3x plus 2 is equal to 0. This is the required polynomial equation they asked to. Let's see. Yeah, x square. So one variable of the quadratic equation, it is 50 x square plus 3x plus 2. X square plus 3x plus 2 is equal to 0 is the required equation, required quadratic polynomial. I hope you understand. All right. Okay, we discussed about two types. First, they give an equation. You can find the sum of zeros and product of zeros like that. And second model is if they given sum of zeros and product of zeros, you need to find the quadratic polynomial like this. All right. Okay, let's move on to the next one. Yeah, these are the few examples they given here. Now, the next concept would be cubic polynomial. Let's understand the cubic polynomial. Hmm. Okay. Okay. Before that, yeah, where we started here. No, not here. Okay, so this is quadratic polynomial 1x square plus 7x plus 2. How can we say that it is a quadratic polynomial, sir? So here the power is 2, the degree is 2. So that is why we can classify it as a quadratic polynomial. When it comes to here for quadratic polynomial, you have only two zeros, that is alpha into beta, alpha comma beta. So, but when it comes to yeah, when it comes to cubic polynomial, how to classify the cubic polynomial? For cubic polynomial, what is the expression? First, we just write the general term, that is ax cube plus bx square plus cx plus d is equal to 0. X square plus bx plus c is equal to 0. Now, for cubic polynomial, how many zeros did you expect? So the zeros are alpha comma beta comma gamma, alpha beta gamma. Okay, previously we taken only two zeros, that is alpha beta. Now it is a new variable that is added as gamma. Okay, now for sum of zeros, let's write it. For sum of zeros, try to take the notes, guys. Sum of zeros is nothing but alpha plus beta plus gamma, that is equal to minus b by a. Okay, and sum of product of zeros, that is alpha beta plus beta gamma plus gamma alpha is equal to c by a, and product of zeros. Take the notes of the important points what I'm writing here. Product of 0, that is alpha, beta, gamma, alpha into beta into gamma. You can take like minus d by a. Observe carefully in the quadratic polynomial. So we have only sum of zeros and product of zeros. But for cubic polynomial, another variable added, that is sum of and product of zeros. Sum of product of zeros. I hope you understand. So these are the required formulas. Based on this, we'll solve each and every question. Okay. Okay, let's move on. Yeah, these are the alpha plus beta plus gamma is equal to minus b by a, and alpha beta, beta gamma plus gamma alpha is equal to c by a. Alpha into beta into gamma, it is minus d by a. I hope you understand. Yeah, we can prove that alpha, beta, gamma are the zeros of the cubic polynomial. Then ax square, ax cube plus bx square plus cx plus d is equal to the all the things I already written for your reference. You just take the notes without seeing the textbook. All right. So these are the three zeros: alpha, beta, gamma. Okay. Yeah. Let's solve the questions. Okay. Well, let's solve the one simple example. Then you can understand better way. Minus 2x square. Okay. Not minus. 3x cube minus 2x square plus 5x minus 9 is equal to 0. Minus 9 is equal to 0. Now let's find the first you just compare with the general form, that is ax cube plus bx square plus cx plus d, and you just write the all the values here. In the place of a, 3 is there. In the place of b, minus 2 is there. In the place of c, 5 is there. You can include the symbols also. D is equal to minus 9. I hope you understand. All right. Okay, now let's find the sum of zeros. Sum of zeros in the cubic polynomial, that is minus b by a. Here minus b is nothing but the place of b, it is minus 2 already there. So minus of minus 2 by a. So finally we got 2 by 3. Okay. And sum of product of zeros. Sum of product of zeros. The formula would be c by a. Let's substitute c by a. C here is 5 by 3. So you'll get 5 by 3 only, plus 5 by 3. And now product of zeros. Product of 0, that is minus d by a. Minus d by a. So you just write like d here is minus 9. Already minus is there. Minus of minus 9 by 3. So you'll get plus 9 by 3. After cancellation, you'll get 3 by 1. All right. So similarly, like quadratic polynomial. So for cubic polynomial, you can find like this: sum of zeros and product of zeros, and sum of product of zeros. All those things you have formulas. All right. Yeah, that's it, guys. Yeah, the same example what we did in the previous example for quadratic polynomial. So we have to verify both the relation between zeros and coefficients. How to find? How to verify? Let's see the read the question properly. Verify 3 minus 1 by 3 are the zeros of cubic polynomial, and verify the relation. Already they given the zeros. What are the zeros they given? Let's start with the let's start with example 5, right? Example 5. Example 5. Example 5. They given like 3, 1, minus 1, comma minus 3. Sir, what is this? All those things. How can we take? So 3 is nothing but alpha they given 3. Beta they given minus 1, I think. Minus 1. And gamma already they given minus 1 by 5. Okay, these are the three zeros. Sorry, minus 1 by 3. Minus 1 by 3. All right. They given the zeros and polynomial equation. Polynomial equation they given like 3x cube minus 5x square minus 11x minus 3. So this is the equation they given. We need to verify. How to verify? First, let's substitute that. So let's take x is equal to 3. I mean alpha is equal to 3. Let's substitute over there. So P of 3, that is nothing but 3 into, in the place of x you just substitute 3 minus 5 into 3 whole square minus 11 into 3 minus 3. 3 into 3 cube. So 3 cube is nothing but 27. 27 into 3. 27 into 3 you will get 678. 81, is that correct or not? 3 cube is 27. 27 into 3 you'll get 81. All right, 81 minus 5 into 3 square. 5 nines are 45. 11 threes are 33 minus 3. Okay, 81 minus 45 plus 33. So you will get 78. 78 minus 3. So you will get minus 81. Finally, we got 0 here. Finally, we got 0 here. So if you got 0, then it is a, I mean 0 as a reminder, then alpha is equal to 3 we have to take. Now one thing is confirmed. Alpha is equal to 3. And now let's substitute let's try with beta is p of minus 1. Shall we do it here or in the next page? 3 into minus 1 whole cube minus 5 into minus 1 whole square 11 into minus 1. In the place of x you just substitute minus, guys, that's it. Minus 1 whole cube is nothing but minus 1. 3 into minus 1 will get minus 3. Minus 5 minus into minus plus 11 minus 3. So you'll get 3 8 3 5 11, 8 8 8 and 3. So you'll get 11. 11 minus 11, that is 0. That is 0. If you get remainder is 0, then you can confirm beta is equal to minus 1. All right. Now let's try with the next. P of minus 1 by 3. Substitute in the equation. That is, what is the equation first? 3x cube, that is 3 into minus 1 by 3 whole cube minus 5x square, that is 5 into minus 1 by 3 whole square minus 11x. 11 into minus 1 by 3 minus 5. Minus 5 or minus 3? Minus 3. Okay. Now let's do the simplification. 3 into minus 1 by 3 is nothing but, so we'll get minus 1 by 27. 3 cube ante 27. And 5 into 1 by 3 square is nothing but 1 by 9. Minus into minus plus 11 by 3 minus 3 by 1. Okay. So finally minus 3 by 27. Okay, you need to cancellation. So you can do the cancellation if possible. So 3 times 9. So you'll get minus 1 by 9 minus 5 by 9 plus 11 by 3 minus 3 by 1. So if you take 9 as a LCM here, minus 1 minus 5 plus 11 3s are 33 and minus 9 3s are 27. Okay, the numerator. Observe carefully. 33 minus 5 minus 1, you'll get minus 6. Minus 6 minus 27, minus 33. 33 minus 33 by 9. So you'll get 0 by 9, that is 0. That is 0. If you get remainder is 0, then we can confirm gamma is equal to minus 1 by 3. So some confusion are there. So be careful while doing with. Why? Because you just substitute over there. So you'll get alpha, beta, gamma is equal to all those things. Let's substitute. Let's confirm. I mean, let's verify. Sum of zeros. Sum of zeros in the cubic polynomial, that is alpha plus beta plus gamma, is equal to minus b by a. Minus b by a. Now what are the alpha, beta, gamma? Just now we got alpha is 3, beta is minus 1, gamma is minus 1 by 3. Alpha is 3. Okay, alpha plus beta gamma, right? Alpha is 3 or 1. 3, beta is gamma is minus 1 by 3 is equal to minus b by a is nothing but minus b by a. We didn't identify any ABC. Okay. Yeah, in the equation 3x cube minus all those things, minus b by a is nothing but minus of minus 5 by 3. Minus of minus 5 by 3. All right. Okay, let's verify. So if nothing else, you can take LCM 3 here. So 3 3s are 9, minus 3 minus 1 is equal to minus into minus plus 5 by 3. So 9 minus minus 3 minus 1, you'll get 4. 9 minus 4 by 3. So finally you got 5 by 3 is equal to 5 by 3. Okay. So you have to verify LHS, RHS like this. Alpha, beta, gamma already you know, and A, B, C already you know, so you just substitute in the formula. Okay. Now let's substitute, find the verification of alpha, beta plus beta, gamma plus gamma alpha is equal to C by A, sum of product of zeros. Alpha here is 3. Let's substitute 3 here. 3 into beta minus 1 plus beta minus 1, gamma minus 1 by 3 plus gamma minus 1 by 3 into alpha 3 we taken. C by A, C by A is nothing but, so here minus 11 by 3, minus 11 by 3. Okay, let's simplify. 3 into minus 1, you'll get minus 3, and minus into minus plus 1 by 3. Okay, here 3 3 get cancelled, you'll get minus 1 is equal to minus 11 by 3. Okay, if nothing else, you can take LCM 3, and 3 3s are minus 9 plus 1 minus 3. All right, minus 11 by 3 on the right hand side. Now minus 9 plus 1, you'll get minus 8. Minus 8 minus 3, you'll get minus 11 by 3. So we verified as both are equal, LHS and RHS. Now let's try with the product of zero, that is alpha, beta, gamma, it is equal to minus D by A. Okay, what is alpha, beta, gamma value? Alpha is I think 3. 3 into minus 1 into minus 1 by 3. Gamma is minus 1 by 3. Minus D by A is nothing but minus 3 by, okay, let's substitute here. Minus of minus 3 by 1. Here, all are multiplication. That's why 3 3 get cancelled. Minus into minus. Once again, where we are doing mistake. Okay, 3 by, I just write 3 by 3. It is 3. Okay. Yeah. So here, minus into minus plus 1 is equal to minus into minus plus 3 by 3. 3 by 3 is nothing but 1. So 1 is equal to 1. So we just verify like this. Okay. I hope you understand. So this is lengthy, I mean, for cubic polynomial, but be careful while solving that. How to verify? First, do one thing. They given 3 minus 1 and minus 1 by 3. We just substitute in the polynomial equation, that is P of x. Take x is equal to 3, x is equal to minus 1, x is equal to minus 1 by 3. Substitute over there. If you get remainder is 0, if you get remainder is 0 in every equation, then you can take that alpha is equal to 3, beta is equal to minus 1. Here they are taken. Alpha is minus 1 by 3 and gamma is equal to minus 1 by 3. Okay. And you can verify by, you just write the formula sum of zeros and product of zeros. Alpha plus beta plus gamma is equal to minus b by a, and product of zeros minus d by a, all those things. You just write like this. I hope you understand what I'm saying. All right. So you just verify like this. Yeah, now exercise 2.2. So before that, still observe carefully, cubic polynomial, it's not an easy condition, easy thing. So yeah, after giving that, you just verify like this. So here they get, if you get 0, then you can confirm alpha is equal to 3. These are zeros of the one polynomial. And by substituting minus 1, you'll get 0. You can confirm beta is equal to minus 1. And gamma, okay, if you couldn't get 0, what you can do? So it is not a 0. You can't take alpha, gamma is equal to minus 1 by 3. If we are getting 0, that's why we are taking gamma is equal to minus 1 by 3. Then let's do the verification part. Verification part started from here. Sum of zeros is equal to alpha plus beta plus gamma is equal to minus b by a. And alpha, beta, gamma, just now we got 3 and minus 1 and minus 1 by 3. I taken at left hand side, and right hand side minus b by a. Okay. So we'll get equation LHS is equal to RHS like this. Okay. Yeah, let's summarize the session. What we then we'll start the exercise 2.2 next session. Let's summarize where we started. Yeah, we just started with the types of polynomial based on the number of terms. Okay, so if the number of terms is 1, we can call it as monomial. If number of terms is 2, so we can call as a binomial. If number of terms is 3, we can call as trinomial. And this is the general form. General form ax square plus bx plus c is equal to 0. For quadratic polynomial, sum of zeros is equal to minus b by a, and product of zeros is equal to c by a. All right. Okay. Yeah, let's end up the session. For cubic polynomial, sum of zeros is equal to minus b by a, and product is equal to c by a. And sorry, product is equal to minus d by a, and sum of product is c by a. Those who want to take the notes, take the notes and everything. Or else you can do, you can write the notes by comparing that like this. So do one thing. So write the quadratic and cubic at one side. Quadratic, we are taking ax square plus bx plus c is equal to 0. For cubic, that is ax cube plus bx square plus cx plus d is equal to 0. Okay. I'm sorry. Sum of zeros, that is alpha plus beta plus gamma. Sorry, only alpha plus beta. So you are getting minus b by a. Sum of zeros here. Sum of zeros here. Alpha plus beta plus gamma is equal to, I'm sorry, once again, the same minus b by a we have to take. And product of zeros, product, we here also product. Product is nothing but alpha plus, alpha into beta. Here also 3 variable alpha, beta, gamma. Why I'm writing all these things? For your understanding without doing any mistake. But I'm sorry, once again. Now the third one is sum and product. Sum of product. Sum of product, you can take alpha beta plus beta gamma plus gamma alpha is equal to c by a. So you just compare like this. All the equation. I mean, this is the table. I make it here. So you just compare like this. For quadratic polynomial, quadratic polynomial, alpha, beta are the zeros. For cubic polynomial, there are 3 zeros, alpha, beta, gamma. I hope you understand. So this table is informative. Try to make the table like this. Okay. All right. I'm sorry, I got hiccups. All right. I just end up here, guys. Thanks for being here in my class. So try to revise all the topics. It's not an easy task to find the cubic polynomial. Okay, for cubic polynomial, you have to pay attention. And today we solved about how to verify the cubic polynomial and the quadratic polynomial, all those things. I'm sorry. Yeah, so I just end up here, guys. Thanks for being here in my class. Okay, let's meet on the next session with the exercise. I mean, we'll solve the exercise 2.2. Okay, and before that, be prepared and revise all the topics. So you have recording sessions also there. Just revise the topics once again. Okay. Yeah. Bye bye, everyone. Have a good day.